Hi, I'm here at the British Geological Survey in Keyworth with Dave Tappin, a marine geologist who's also an expert on tsunami. Now, as many of you know, there's been a massive earthquake in Honshu in Japan, and it's probably the largest earthquake since Japanese records began. Now, this earthquake is many times more powerful than the earthquake in Christchurch in New Zealand. Now, Dave, I wonder, could you tell me what is a tsunami and how does it, or what causes it?
Tsunamis are obviously created by earthquakes, as we heard on the TV and the radio this morning. But basically, to create a tsunami from an earthquake, all you need is a step in the ocean created by the earthquake rupture. Okay?
Yep.
And the magnitude of that step is dependent upon the magnitude of the earthquake. You need an earthquake larger than 7.5 to create a dangerous tsunami. The earthquake this morning was about 8.9, is 8.9.
Yep.
And what happened is during the rupture, you have a step in the sea floor.
Yep.
Along the rupture zone, and the rupture zone this morning is probably 300 or 400 kilometres long. And then what happens is that the step propagates up through the water column. And at the surface you have an analogous dislocation. It's unstable, collapses, and the tsunami propagates out to either side.
Okay, Dave. Can you tell me, about the progress of the tsunami? Does it go generally in one direction, or does it go in all directions at the same time? How does that happen?
Along a linear rupture, what happens, if you think about what I just said about the step in the seabed along the rupture zone, it propagates initially in a linear fashion to either side. Okay. In the instance of the tsunami this morning, it was about 100 miles offshore, so it propagated to the west, striking the northeastern shore of Japan. It travelled very quickly. The initial wave might have been meters high, but as it moves across the ocean, it's probably half a metre, a metre. As it approaches the shore, because of the sloping seabed, what happens is the wave builds up. It's not one wave, it's a number of waves. These slow down because of friction with the seabed. As the seabed shallows, the waves slow down, they catch up with each other, and they can build a tsunami which this morning was certainly 4 metres, if not greater, in height. That's in the near field. In the far field, what happens? In larger oceans, Indian Ocean, Atlantic and Pacific, what happens? The tsunami will also propagate in a generally eastward direction. What happens is that the actual wave itself, again, is quite benign. It's maybe half a metre, a metre. You wouldn't notice it on the ocean if you're on a ship, if you're flying over it. It travels very rapidly. It doesn't maintain its linear nature. What happens as it moves across the seafloor, it is affected by the seabed topography, and it refracts and diffracts, and generally it doesn't exactly lose its energy, but what tends to happen is it does become more circular as it progresses outwards.
Okay. In this particular case, how far will this tsunami get, Dave?
This tsunami will travel certainly around the world. 8.9. The Indian Ocean's tsunami of 2004, magnitude 9.3 earthquake, went 3 times around the planet. It was measured in the Atlantic, it was measured in many locations. Fortunately for us in the Atlantic, it was only centimetres high.
So you still measure the effects here?
Yes, this will be measured by tide gauges, which are set up particularly in real time to measure the tsunami waves. This is part of the mitigation, this is part of the warning system.
Now, usually with an earthquake, Dave, especially one this powerful, there are some quite significant aftershocks. Do they pose a tsunami risk as well?
There are aftershocks, that's right. This earthquake was 8.9, as I've said. The aftershocks will be probably orders of magnitude less. The largest ones, maybe 7, a little bit larger. As I've already mentioned, you need a magnitude 7, 7.5 to create a dangerous tsunami. So my estimation is it's unlikely that there would be a large tsunami associated with any aftershock, associated with this earthquake.
Dave, thank you very much.